Yes. Now, today I want to emphasize to you. Good morning. Today I want to emphasize three things. I want to emphasize. I want to emphasize. I want to emphasize gradient. Then I emphasize divergence and curl. So we are going to first of all start with the gradient. The gradient of a scalar or scalar. Of a scalar function. When you talk of a scalar function, what we mean, even if you're given a function phi, others can call it f, others can call, we are going to use abstract letters, and it is a maybe of x, y, and z. A scalar function, for example, like this one, ax z cubed minus 3x squared y squared. We are calling it a scalar function because you're not seeing any I or j there. So once you see there is no ij, just know that is a scalar what? That's a scalar function. And if I'm interested in maybe getting the gradient, which I can write like that, which can be the same as that, which can be the same as that, x, y, z. By definition, let me choose to deal with one. This one is defined as the f, the x, this one will give me the I component plus the f, the y to get the j component plus the f, the z to get the I, the k component. So in the video, if you manage to see the video, they had written the i's first. It is still the same thing. It should not what? It should not bother you. It is still the same. It is still the same thing. So our interest now is going to be, we are going to, what is our the f, the x. That means we're going to differentiate this whole function, but with respect to what? To x. And this one will give us ax. I'm assuming people know how to differentiate. If they don't know how to differentiate, that would be trouble. So this one is ax, az minus x. That one will give you 6xy what squared. Now if you differentiate the f with respect to y, so we're differentiating the whole function but with respect to y, so this is 0. So here we shall have minus 6x squared y. Then the component, the f, the z, it will give you 3ax z squared. Okay. Now where there is this one, you'll be writing this one. Where there's this, you'll be writing that one. And where there's this, you'll be writing that one and put ij. That means the change in f would be az minus xy, that's the I component, plus the y component, because it is minus, so the plus will be affected by that one. So it will be minus 6x squared y, this is in the j, plus this component is 3ax z squared, this is in the what? That's why they tell you that when you take the gradient of a function, what you get is a vector, because it will be having ij and what? And k. So this is how they compute the gradient of a scalar what? Of a scalar function. Okay? Now, since now we have seen how to compute the gradient of a scalar function, now let us see how do we compute the divergence of a given what? Of a given function. Divergence. Divergence. Now suppose your f is f which is x, y, z. So suppose it is given by x squared yz yz, this is in the I, plus y squared plus this is z, this is zx in the j, plus z squared plus, this one might not fit here, but what I'm saying is plus z squared plus xy, this is in the k direction, you can just put it there. So you must know the definition of divergence. Divergence, it is always if this one takes components, it's just the sum, right? dy plus the fz dz. That is by definition. So now this one is the fx component, this one is the fy component, and this one is the fz what? Fz component. Okay, so what you need to do is you're going to see how we are going to solve them. Remember, I've said fx component, the fx component is given by x squared plus yz, then the fy component is given by y squared plus zx, and the fz component is given by z squared plus yx. So you'll first of all compute, you are going to take the change in fx component but with respect to x. This one gives you 2x. When you differentiate this one with respect to y, it will give you 2. This one goes to 0. Then the fz with z, this one gives you what? 2z. And the divergence, by definition, it is just telling you it is the sum of the, just the sum of, this is y plus this is dz, then you just sum up them. So the divergence will be 2x plus 2y plus 2 plus 2z, and this will be your answer. Just simple like that. So when you come to a curl, I know where this is where the problem is. So one thing you should know, that for the case of if you are dealing with the divergence, you must be given a vector quantity. So divergence converts a vector quantity. You see, you start with the ijk, converts a vector quantity, and you get what we call a scalar what? A scalar quantity. Now, how do you compute the curl? Curl, let us assume that if, let us suppose that we have our f, our function, is given by 3yi minus 4x. And I want you to be very attentive on this one. Even the curl, will always take a curl of what? A vector. You cannot take a curl of a scalar quantity. That one cannot work. You'll always take curl of a vector. You'll always take divergence of what? Of a vector. Now remember, curl is written like this. We say the first write the first column, the first row has the ijk. The second is followed by this one, which is the changes, the partial derivatives in all the directions, then followed by these components. This one, that one is the I component. The j component is not there, but we are given the k component. So when you are filling in here, so here I'll put 3y. The j component is 0, but the k component is negative 4x squared. Now troubles here. How do we solve? How do we solve that? Okay. The question is, how do we solve that? You are going to get the determinant. And what do you mean by the determinant? The determinant, what I mean by the determinant, this is where the problem comes in most of the times, is how to compute that. And I want to show you today how we compute that. If I want to get the I component, what I do, this is what I do. I want to use a small demonstration here. But if I want the I component, you close the I component. You close the I component. You will see that you remain with a 2 by 2 matrix. So you take the determinant. The determinant is always this one minus that one. So the I component is always given by, so it means this one, multiply it here, so it will give, that means you're going to differentiate negative 4x cubed with respect to the x minus product of that one, which is differentiate, that is 0 over dy. This is a bracket. Now for the j, you close j, but j you always put a negative. Negative, it is a fact, you always put a negative. So you will take this one, take away that one, so you'll have d, the respect. Sorry, this one should be, there's a mistake here, let us correct. This is dy, and this is what? Sorry, this is dz, this is what? dy. So here we need to correct this one, dy, and this is what? Sorry. So here, when you close there, so we shall have this one multiplied by that one. This is negative 4x cubed dx. Take away d. This is dz. This is 3y plus, now the k component. K, you put the k here. You close the k. So do you see you remain with this one? This one and that one, and that. So the k, so we shall have d. You multiply them, minus d. Okay. So what this one tells you, if you look at the I component, what this one tells us, that we are going to differentiate this function with respect to y. But this is for x, so this one will be 0. This one is already 0, so 0 minus 0 is 0. So when you come here, this is minus 4x squared, x cubed. So when you differentiate with respect to x, we shall have negative. Remember here we have now, this is 0, 0i minus j, but inside here we have minus 12x squared. This one z, this is y, that will be 0. So minus 0 plus k. K, this is 0, and this is just minus what? Minus 3. So So you're differentiating 3y with respect to y, which gives you 3. So your answer now becomes a negative, so it becomes 12x squared j minus 3. Okay. So, and that one will be your what? That one will be your answer. And you'll be ready to go. That will be your answer. Okay? Simple as that. Are we together? Simple as that. So that is the emphasis I wanted to lay on curl vector. On the curl of a vector, the divergence of a vector, and the gradient. Yes, have a blessed day.